So let's look at an example. When would we use it? So we started off with f of x equals x to the 10 power. And we want to find the derivative, f prime of x. Well, to do that, all we have to do, so according to this, we have x to the n, so in this case n is 10. So to do that, we write n down. So we take this 10, bring it out front. Then we have x, and then we take n and we subtract 1 to the 9th power. There's our derivative. Let's do another example. Let's say we have y equals x to the 50th power. If you want y prime, now listen carefully, you take your 50, bring it out front, 50, x, and you subtract 1, 49th power. So this power rule is very useful. It definitely makes finding the derivative of, in this case, when you have an exponent basically, makes that very quick. Because you just bring down the number, write it again, and then you subtract 1. And so there's our power rule. Let's try a couple more about this example. Let's say we have f of x equals x to the 2/3 power. Now, if we had to use the definition of a derivative to find the derivative of x to the 2/3 power, that would probably be very challenging. But now that we have the power rule, it's actually pretty straightforward. F prime of x equals, so you bring down the 2/3, x, and then you subtract 1. So 2/3 minus 1 is 2/3 minus 3/3, so it's a negative 1/3. So our derivative will be 2 over 3x to the 1/3 power. Very handy. And then we have this case here, which makes things a lot easier. Let's say we had f of x equals 1 over x. Now we actually we actually found the derivative of this using the definition, and it wasn't too bad. But why don't we rewrite this? We have f of x equals x to the negative 1 power. Now we can use the power rule. F prime of x equals a negative 1 x, and then we subtract 1 to the negative 2. So f prime of x equals a negative 1 over x squared. So as you can see, this power rule is very useful, and whether you have a power with a very high exponent like 50, or you have a rational exponent like 2/3, or you have a negative exponent like to the negative 1, using the power rule is fairly straightforward. Okay, let's look at a couple of other rules. One is the constant rule. Amazingly, this one actually trips up students a lot. I'm not sure why, but if you have a constant f of x equals c, then f prime of x equals 0. So that's the constant rule. So let's say we have f of x equals 3. Okay. Now if I were to quickly sketch this, and this is just a line, horizontal line at 3. That's it right here. So the slope of that line is 0, no matter where you are. So the derivative is 0. That's it. And sometimes, you put down, y equals, if I have y equals 9, and I say, what's the derivative? Some students are like, 9x, and it's not, it's just 0. Okay? In another form, if I ask you to take the derivative with respect to x of pi, that's just 0. So don't get confused by that one. It's actually quite simple. Now we have the constant multiple rule. Okay, so for the constant multiple rule, if I have y equals some constant times f of x, then the derivative is just going to be that constant times the derivative of x. Okay? So let's look at how this one might work. Let's say we have f of x equals 5x to the fourth. So we have a constant in front of that. Well, when you take the derivative of this, just kind of leave the constant alone at the beginning, because all we have to do is take the constant and multiply by the derivative of this function. So f prime of x is going to be 5, just leave that out front, and then we take the derivative of x to the fourth. So we bring down the 4, and we subtract 1. And then we get f prime of x equals, well, 5 times 4 is 20x cubed. Okay. All right, now I did this in 2 steps. I would say almost everybody who ever does calculus does this in 1 step. We go from here to here. So let's look at another example. Let's say we have y equals a negative 3x to the, I don't know, 4th power. So then y prime, so don't do 2 steps, just say, well, 4 times negative 3 is a negative 12x cubed. And there we go. You have your derivative. Alright, let's do another rule. We're going to have the sum or difference rules. And this one just states, I'll just do the sum version, if y equals f of x plus g of x, then y prime is going to equal f prime of x plus g prime of x. So if you have a situation where you have 2 functions being added together and you want to take the derivative, well then all you have to do is take the derivative of each one and then just keep them, add them together. So let's look at a couple of examples. Let's say we have f of x equals 11x to the 8th power plus 2x squared. And we want to take the derivative of that. Well, because we have a sum of 2 functions, 11x to the 8th and 2x squared, we can take the derivative of each one and then just keep them that they're added together. So the derivative of 11x to the 8th, well, you bring down the 8, so 11 times 8 is 88x, and then we subtract 1, x to the 7th. And then here we bring down the 2, 2 times 2 is 4, x to the 1st. And there would be our derivative. Let's look at this example here. And I'm going to do this example because sometimes this bothers students. They don't know what to do here. But if I have f of x equals x to the pi power minus 6x cubed. And so sometimes books will throw in a pi just to kind of see what you do. This is not, because remember, pi is just a number. So to take the derivative of that, we would have pi x, and you can't, there's no way to subtract 1. So we'll just say pi minus 1 power, and we'll subtract 18x squared. And that would be the answer to this one. Okay, so in this video, we went over the power rule, and we went over the derivation of the power rule using the binomial theorem. One thing to kind of know, there are teachers out there that will actually put this on a test. So, it might be something you want to know how to do for a test, but you never know. Some teachers might not, but some teachers may. So you have the power rule, and then from the power rule we were able to see that it was much easier to find the derivative, much more efficient to find this derivative. And then we had the constant rule, constant multiple, and the sum and difference rule. So basically, these last two examples were good examples of putting all those rules together.